Hello students, very good morning to everyone. Today we will discuss the next topic after the remainder theorem. This is factor theorem. This is also an important theorem. So first we will just look on the statement of factor theorem, that what is factor theorem. You can say first that what is factor. So before discussing the theorem, we will discuss the factor. What mean of factor? You all have studied in previous classes about the factor. Simple things, suppose 36 is a number, so by doing the prime factorization or just doing the writing it into multiple of numbers, so this is 1 into 2, 2 2s are 4, 3s are 6, and 3s are 36. So this 1 into 2 into 2 into 3 into 3, all the numbers, these numbers are what? The factor of this. This can be also written as 2 2s are 4 into 3 into 3. This can be written as 9. This can be written as 2 3s are 6 into 2 into 3. This can be written as like this, and many more. So the definition of factor is this, that the number which divide the given number, that is known as what? Factor. The number which divide the given number is known as the factor of given number. So this is the basic definition. So this is a small look on the factor, that for any given number, those numbers which divide the given number is known as what? Factor of the given number. Similarly, the number in polynomial also, the polynomial which divide the given polynomial is factor. So now here we will discuss that factor of a polynomial. Factor of a polynomial. So what is the definition of factor of polynomial? Means the polynomial which divides completely the given polynomial is called factor of polynomial. Like just in previous classes we have discussed that x square plus 4x plus 4 is divisible by x plus 2. So this x plus 2 is what? X plus 2 is factor of x square plus 4x plus 4. Now this is the definition of factor. We are not discussing at the factor theorem, factorization theorem you can say. So this is definition of factor of polynomial. Now note it. If you have done, then we will proceed that as like in number, if a number is divisible by any given number, if a number is completely divisible by any given number, then what comes? That 2 2s are 4. The important thing is that when a number is completely divisible by any number, then remainder is always 0. The same thing will happen here also, that if a polynomial will be divisible by completely divisible by polynomial, then the important thing that a remainder should come 0. What? 0. This is important thing, that if any polynomial is completely divisible by any, then the remainder should come 0. So this point should be learned. On this point we will move to the statement of factor theorem or factorization theorem. So statement is what? Now we have two definitions, that factor and second topic was remainder. You can say r is equal to 0 when the completely divisible. So factor means which divides completely. So on these 2 points, combining these 2 points, we will say that if x minus a is a factor of polynomial px, then pa is equal to 0. Then pa is equal to 0. Why we are writing pa is equal to 0? Just before this topic we have discussed that r should be 0 when number is completely divisible. R is what? Remainder. And in previous theorem, remainder theorem, we have studied that when px is divided by x minus a, then pa is remainder. Here we will say that if x minus a is factor, means x minus a completely divides px, then remainder should be equal to 0. Or if pa is equal to 0, means remainder is 0, then x minus a is factor of px, where px is polynomial of degree n greater than or equal to 1. Means px, just like yesterday, कल की तरह px एक ऐसा पॉलिनोमियल है जिसकी डिग्री कुछ भी हो बट वो 1 या 1 से ज़्यादा ही होना चाहिए, एंड a is any real number. So this is the statement. You can combine this also, that if x minus a divides px, then x minus a is factor if and only if pa is equal to 0. I am writing this into two statement. First is here, you can say, and second is here, that if x minus a is factor of polynomial px, then pa is equal to 0, remainder 0. If remainder 0, then the x minus a will be factor of px. So simply this is the statement. Now what will be the use? Any example? So you can take x square minus 6x plus 9 is, you can say, check x minus 3 is factor of x square minus 6x plus 9. Or not. Check, is x minus 3 factor of x square minus 6x plus 9 or not. Now in this question you will not proceed to divide this polynomial by this, and in the last when remainder will 0, then you will say this is factor because it is dividing. No need to go the complete process. We will use this factor theorem or factorization theorem. What is factorization theorem? That if x minus a factor, then pa should be 0. Simple. We will use this कि अगर फैक्टर होगा तो रिमाइंडर 0 होगा, और रिमाइंडर 0 होगा तो फैक्टर होगा. So we will check that this is factor or not. So we will find out the remainder. So the solution will be what? We will find out the remainder. Like px is equal to, we will represent this as a polynomial px. So p, what is the value of a? You can write x minus 3 is equal to x minus a a is equal to 3, a is equal to 3. So pa means p3 is equal to, just put the value, p3 is equal to 3 square minus 6 into 3 plus 9, 3 3 is 9 minus 18 plus 9. So 9 9 18 minus 18 is equal to 0. Now p3 is what? Remainder, and remainder comes 0. Remainder is coming 0. Remainder is coming 0. So we will say that this x minus 3 is factor of x square minus 6x plus 9 on the basis of factorization theorem. Why? Because remainder is 0, so x minus a is factor of x. Because x is equal to 3 पर रिमाइंडर 0 आया, so हम लोग कह सकते हैं x माइनस 3 इस पॉलिनोमियल का फैक्टर होगा. अगर ये 0 नहीं आएगा तो फैक्टर नहीं होगा. दैट्स ऑल. दिस इज द फैक्टराइजेशन theorem. You can note it. This is the comparison you can do either roughly or here you can do. So note it.